so we're gonna finish off our chapter 4. I'm so happy. So, Bismillah, let's get it. Final subtopic 4.5, metallic bonding. Alright, so macam biasa, let's look at our learning objectives. So today, we will learn how to explain the formation of metallic bond by using electron C model. So, we'll get to know what is the electron C model. Then we're going to relate metallic bond to the properties of metal. So what is malleability, ductility, electrical conductivity, and thermal conductivity. Then we're going to explain the factors that affect the strength of metallic bond. Okay, and finally relate boiling or melting point to the molecular structure, types of bonding, and intermolecular forces for elements of period 3, group 1, and group 17. Alrighty. So, firstly, if you look at your periodic table, the elements on the left and in the middle of the periodic table, except hydrogen, are metallic elements or metals. So, these elements can form metallic bond. So, what is metallic bond? So, metallic bond, it is an electrostatic force between positive charged metallic ions and the sea of delocalized valence electrons. Okay? So, look here. Your metal, you have positive ion, sodium plus ions ni. You have the positive ions. And you also have the free moving electrons. So this, the electrons, they are freely moving. Okay? The electrons are moving while the metals are not. So, the metals are closely packed in the solid state. Okay, the metallic bond can be imagined as an array of okay, so ni lah. The metals are closely packed in the solid state. Okay, very closely packed. So the solid lattice is held together by the strong attractive forces between the delocalized valence electrons ni, electron ni, and positively charged ions. Okay, lattice here means susunan berlapis-lapis, layers of this arrangement here. So the solid lattice of your metal, it is held together by the strong attractive forces between the freely moving electrons and the positive ions. Okay. Okay? Right. So, I want to show you how the sea of electron looks like in motion. So, in this GIF, you can see that the electrons are freely moving, randomly moving. Okay? And your ions, acah-acah lah, they are vibrating at a rigid position. Okay? So, that's how it looks like. Okay. So, what are the physical properties of your metals? Okay. If you have metals, how does it look like? Apa yang awak nampak? Apa yang awak nampak? Apa yang, what can you, apalah sifat-sifat metal tu? So, the physical properties of your metals are as follows. You have malleability, or in Malay it is kelenturan. Ductility means kemularan. First time saya dengar ni, I just googled what it is in Malay, mana tahu awak tahu kan. Then you have electrical conductivity and thermal conductivity. Okay. So, firstly, what is malleability and ductility? So, malleable means it can be pressed into different shapes. Ductile means it can be pulled into a wire. Right. So, metal atoms are arranged closely packed. So when sufficient force is applied to your metal, one layer of atoms can slide over another without disrupting the metallic bond. How does that look like when force is applied? Okay, in this GIF, you can see that when force is applied on your metal, the layer of atoms do not, it's not this, apa ni, dia tak break apart, It doesn't break apart, but the layer of atoms, they slide over one another. And the metallic bonding is still intact. It is not disrupted. Okay? As a result, your metals are malleable and can be drawn into wires. So that means metallic bonding is what allows your metals to be shaped into wires, because they won't be cut like non-metals. Macam contoh kalau plastik kan, awak boleh easily cut it, but metals you don't easily cut them, okay? Because they have this special character, metallic bonding. Alright? Okay. So electrical and thermal conductivity. So metals have high electrical and thermal conductivity. So can conduct electricity and can conduct heat. Because the sea of delocalized electrons are free to move from one end to another end when there are differences in electrical potential or heat. Okay, what does that mean? How does that look like? It means that when a voltage is passed through, contoh saya letak voltage, voltage apa daripada bateri kan? So voltage is passed through a metal. It pushes the electrons, okay? It pushes the electrons so that they flow through the metal, okay? So when there is voltage, there is current, kan? Moving, your electrons are moving across your metal. When there is no current, the electrons will move randomly, like the blue GIF I showed you just now. Okay, so when you put current, then your electrons will flow through the metal. Okay, alright. Metallic bonding ni sikit je. So the factors affecting the strength of the metallic bond. Okay, the strength of metallic bonding depends on two things. You have size of positive metal ions and you have number of valence electrons. So the strength of metallic bonds is directly proportional to the number of valence electrons and inversely proportional to the size of atom. So maksudnya macam mana tu? Remember bebal? Do you remember? Beryllium, boron, aluminium from periodic table chapter 3. So these elements, kita recall, it can achieve incomplete octet. So they are positively dense, so very small but with a very high positive charge. Okay, contoh I mean itu contoh untuk what am I trying to say? Okay, so if the strength of metallic bond is directly proportional to the number of valence electrons kan, so that means if you have more number of valence electrons, then the strength of your metallic bond will increase. Okay, and it is inversely proportional to the size of atom. So lagi banyak valence electrons and lagi kecil size of atom, then the stronger is your metallic bond. Okay? Boleh? Write it out so that you can see it clearly. Right. Oh. Sorry, saya tak perasan ada lagi satu point. So the smaller size of positive metal ions and the more number of valence electrons will exert stronger attraction of metallic bond. So basically what I just said just now lah. Okay. Lagi kecil size your metal ion, and the more valence electrons it has, therefore stronger metallic bond. Okay. Okay, next, effect of the strength of metallic bond on boiling point. So how does metallic bond affect your boiling point? So the boiling point of a metal depends on the strength of a metallic bond. Okay. So the stronger the metallic bond, the higher the boiling point. Make sense? Because high energy is required to overcome these strong electrostatic forces between the positive ions and the delocalized valence electron C in the metallic bond. Boleh faham point ni? Okay, boleh kan? It's not that hard. So, for this example, we're going to explain the difference in the boiling point of the two metals given. So, here you have magnesium and aluminium. So, the boiling point of magnesium is lower than the boiling point of aluminium. Okay. So, agak-agak apa yang kita nak compare ni, guys? So, what do you think we're going to compare about? Okay. Just now, we know that metallic bond, strength of metallic bond is directly proportional to the number of valence electrons over size of positive ion, right? Okay. So you're going to talk about the cation radius of your atoms, okay? So maksudnya aku kena cakap pasal apa? They are from different groups, right? So you're going to talk about across the period gitu. Atau just talk about which ion has larger cation radius, macam tu. And then you're going to talk about the number of valence electrons. So magnesium is in group 2 and aluminium is in group 13. So magnesium will form magnesium 2 plus ion. Aluminium will form aluminium 3 plus ion. Okay. So the strength of your metallic bond in which atom is stronger, guys? So which one? So the strength of metallic bond in aluminium is stronger than in magnesium, because aluminium has 3 valence electrons and a smaller cationic radius, while magnesium has only 2 valence electrons and a larger cationic radius. So the strength of metallic bond is directly proportional to the boiling point. Therefore, the stronger the metallic bond, the higher the boiling point. Okay, because more energy is required to overcome the metallic bond. Okay, is that clear, guys? Boleh kan? Alright, sudah habis. Okay. So, end of subtopic 4.4 and 4.5. Alhamdulillah, finally, guys. Alright, so what I want you to do is, what you should do, ni nanti saya betulkan lah dekat dalam the final notes. I want you guys to make nice notes, okay? Which covers the important points from these two subtopics. So how to know what to include in your notes? Then you should read and understand about this topic first, these two subtopics, and then extract out points that you will use, points for you to apply in your tutorial questions. Okay? Contoh nak tunjuk ke tak? Stop. Okay. What I did, ini saya buat nota sebelum saya jawab. Because of course lah kan, kalau tak nanti blur. Tu pun blur juga kan. So what I did was, I did like a rough mind map about what is in the subtopic, and then I did macam how to compare strength of forces for boiling points, for solubility, density. You should do that, okay? Macam tu. And then I did how to apa ni? How to determine the important points, macam which intermolecular force is stronger, weaker. Okay? Okay? Benda macam tu. So macam, then for van der Waals forces, what are you going to what are you going to compare? Stuff like that, okay? So this is just macam my rough notes. Maybe dia terkurang terkurang information, atau you know, you can do better notes than me because I kan student. So do that, okay? And then do your tutorial questions. I'm going to upload them and put it as assignment. And after we finish, okay, nanti chapter 5, I will set up new Google Classroom using MOE because MOE account, because I just got them. So yeah guys, see you later and good luck for your UPS too. Study, okay? It's going to count for your for your marks in the exam, for your apa-apa lah. Okay, good night. Bye-bye. Thank you.